So for today's myth, we will be doing can tap.
The myth states that when you shake a can and tap it on top of the can, it will not explode. So what's scientific behind this?
Well,
Carbonated drinks contain dissolved carbon dioxide gas.
this is what causes the pressure to build up when the can is unopened. Gas is dissolved in the liquid because the mixture is pressurized, resulting in the pressure inside of the can being higher than the pressure outside of the can.
When you shake the soda can, gas escapes the solution or the Coke, and since gas is less dense than liquid, the gas rises and is waiting to escape through the top of the can.
When shaken and open, gas rises trying to escape. During this, the gas pushes on the liquid upwards. In addition, gas bubbles are stuck at the top, bottom, and sides of the can. When open, the bubbles rise, pushing all of the liquid in its way upwards. The gas also contributes to the pushing of the liquid upwards.
When you tap on top of the can, you're knocking bubbles off the top and sides of the can, making them rise to the top. Since the bubbles are waiting at the top of the can, as the can opens, there is no liquid in the way of the bubbles. So Ryan, how do we test this myth?
Well, first of all, we need a control group and an experimental group.
Control A is on the right, experimental B is on the left. For control A, we shook it 10 times and didn't tap it. For experimental B, we shook it 10 times and tapped it 10 times. For this whole experiment, we're going to shake the cans 10 times each.
But before we test the cans, we're first going to see if the time interval between shaking the can and opening the can makes a difference.
For the first one, we're going to wait 0 seconds. And for the second one, we're going to wait 5 seconds. For the third one, we're going to wait 10 seconds. You ready?
I'm ready.
I'm ready.
Let's go.
Okay, let's go. Shake it 10 times. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Woo! It exploded! Okay.
Okay.
Now this one. That's the
For
second
this one.
can.
This one's the second one, so we're going to wait 5 seconds. But we're still going to shake it 10 times. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
1, Mississippi, 2, Mississippi, 3, Mississippi, 4, Mississippi, 5, Mississippi.
Woo! Well, there's less.
Still exploded though.
Next one. 10 seconds, wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi, 7 Mississippi, 8 Mississippi, 9 Mississippi, 10 Mississippi. Still exploded.
So as you can see, there's a difference when we wait in time. We'll be testing group A. We're gonna shake it 10 times and 0 seconds. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
1, 2, 3, 4, 6, 7, 8, 9, 10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Now we'll be testing group B, which is the experimental group. For this, we'll be shaking it 10 times and giving it 10 clicks on the top.
Ready? One, two, three, four, five,
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So in conclusion, our hypothesis was correct. After shaking the can and tapping the top of the can, it still exploded. So, this myth is... For control A, remember we only shook it 10 times without tapping it, so the volume remaining is less than B. For experimental B, we shook it 10 times and tapped it 10 times, so the volume remaining is greater than A. Yes?
Okay, go.
So, for control A, the average remaining volume is 225.5 milliliters, and for experimental B, the remaining is 346.72 millimeter.
So for today's myth, we'll be doing can tap. I'm serious, stop. So for today's myth, we'll be doing can tap. So for today's myth, we'll be doing can tap. So for today's myth, we'll be doing can tap.
The myth states that when you shake a can and tap on top of the can...
So today's myth, we'll be doing can tap.
The myth. Cans from A and B. And we're just gonna shake the can.